Hello and welcome. We will be starting module 2, which is basic computer organization and design. Okay, and in this series we'll be going on with understanding the different topics of module 2, such as how computer systems are organized and what their design is and how they work. So without further ado, let's get started. In this video we'll be discussing an introduction. So it will be the basic computer organization, its operations, what sort of register transfers does it have, and what sort of instruction format does it have. The topics will be covered as follows. We'll be referring to the first topic in this video. We know that the basic format of a computer is as follows. We have input and output devices, we have memory, and then we have the processor that has the control unit and the ALU, which is the arithmetic and logic unit. It is used for performing arithmetical and logical operations. The instructions. So basically a program is a sequence of instructions. So whatever program we run, it has a sequence of instructions. Now the instruction on a smaller level is a group of bits that tell the computer to perform a specific operation. So those bits are used for performing an operation which the computer decodes, and they make up an instruction. The instructions of a program along with any needed data are stored in the memory, so we can find the data and the instructions in the memory. The CPU reads the next instruction from the memory, and the instruction that we are going to be executing will be placed in the instruction register, denoted by IR for short. The control circuitry in the control unit translates the instruction into the sequence of microoperations and hence the execution. Instruction codes. So these are a set of bits that command the computer to do a particular operation. It is distributed into segments, or you can say different parts, and that is which we will be understanding. These codes as well as data are stored in the memory, and each instruction is read by the computer and placed in a control register. The control unit then understands them and helps in executing and passing instructions for the execution of the micro operations. The instruction code format. An instruction code is a group of bits. So these bits are what instruct the computer to perform a specific operation. It is mainly divided into two parts, which is the opcode, also known as the operation code, and the address. The opcode is this part that defines what the instruction or the operation will be, such as addition, subtraction, shift, complement, and multiple more operations that will be carried out depending on the architecture of a specific computer system. The second part is the address part. This is what specifies the registers or locations in the memory. It has the address for the operands that will be used for the operation. So basically we have the operation over here, and then we have the operands, that is the data on which the operations are going to be performed. The length of a typical instruction code is 0 to 15 bits, thus a total of 16 bits is the length. We have the address of 12 bits, hence ranging from 0 to 11. Then we have 4 bits for the opcode, and in those 4 bits we have a single bit that is used for determining the addressing mode. We'll discuss this further on. So the 15th bit, or in the instruction code format, is the addressing mode. We can see from this that the number of bits required for the opcode depend on the total number of operations that the computer has. So mainly it is 2 power n operations. So if we have about 2 power n operations, then we'll have an n bit operation code. So if we have 8 different operations, we would have 3-bit operation code, as we studied earlier in the instruction code. So if it's a 3-bit operation code, then that means we have 8 different operations in our computer system. Now the format that we are studying is the format of a basic computer system. It can vary based on different questions and based on different computer architectures. Some may be bigger and some may have the same size as the one we've studied. So here we have an example of a computer system that has the opcode of 6 bits, and thus since 6 is n, so 2 power n different operations that can be performed, This would give us 64 different operations for such a computer system. So the person who designs the computer architecture, they have specified that add in this certain system is given by the following opcode. Okay, so when the control unit reads it from the memory and it sees that the opcode has the following digits, then it is able to tell that it is an add operation. Instruction code address. So the address part is what we'll be referring to now. An operation is specified by the operation code, fine, the opcode, and it must be performed on some data. Okay, there has to be some data that it will be performed on, and this data is stored in either registers or in the memory. The instruction code therefore specifies not only the operation but also the location at which we'll find the data and where we'll be storing the result. This is the address part. So the operand is read from memory, okay, and is used as the data to be operated on together with the data stored in the processor registers. The address is what specifies the place where the operand can be found in the memory or in the registers, so that the operator, the opcode, can perform the operation on that data. Each computer has its own specific instruction code format, which is conceived by computer designers to specify the architecture of the computer. Thus stated that the instruction code format is not always the same. It may vary based on different designers, and we are studying a basic common format of the instruction code. Since we discussed that the 1 bit, that is the last 16th bit of the instruction format, that determines the addressing mode, we will now look at what types of addressing modes there are. So there's basically 3 different types. The immediate addressing mode is when the operand that needs to be used for performing the operation is given directly in the address portion. So since we divided the instruction code into 3 parts, there was the opcode and then there was the address part. The operand will be given directly in the address part instead of having its address over there. Okay, so we'll find the operand in the address. The second type is the direct mode, where the address that is given will be pointing towards the operand in the memory. Okay, so the address that is stored in the instruction format in the instruction code will be pointing towards the operand that is stored in the memory. Hence, when we visit that memory place, we will find the operand stored over there, and hence we will perform the operation on that operand from the memory. The third type is the indirect address. The indirect address points to another address, so basically it's an indirect reference to the operand. So the address in the instruction code points to another address which will have the address of the operand in memory. So it will indirectly be pointing towards the operand through another sub address, and hence at the final address we will find the operand in the memory and the operation will be performed. The 1 bit of the instruction code can be used to distinguish between direct and indirect access. The immediate access is not used in the format, so the direct or the indirect is determined by the 1 bit in the instruction code. The types of addresses, as we discussed earlier, immediate operand is the one directly in the instruction code. The direct access is when the address specifies the position of the operand in the memory. The indirect access is the address that points to another address which tells us where the operand is in the memory. Finally, we have the effective address. So the effective address is the address of the operand in the memory. So no matter whether it's pointed indirectly, directly, or whether it's intermediate, the effective address is the address of the operand where it is stored in the memory. Okay, the address of the operand of a computational type instruction, or the target address in a branch type instruction. The direct and indirect addresses can be determined as follows. So if we have an instruction format with the opcode and the address, it is a 16-bit instruction format, then in memory this is how it's going to be presented. The 0th bit shows that it is direct access, hence it is direct addressing mode. The opcode over here is add, that means the operation that needs to be performed is addition, and then we have the direct memory address towards the operand. So 457 over here is the address of the operand in the memory. Hence when we go visit 457, we will find the operand over there, and on that operand we will be performing addition, and it will be stored in the accumulator register. The accumulator register we will discuss in brief over here. It is a register that stores manipulated data. That means any operations that are performed on the data are stored in the accumulator. Okay. The effective address, as we see here, is the address of the operand. So wherever the operand is stored, that will be the effective address. We have the second example over here of indirect addressing. So when our addressing mode bit is 1, it means it is indirect addressing. Again, the opcode is for addition. We have the address 300. Okay, so when we visit the address 300, we will find the address 1350. Okay, we'll find the address 1350. So you see, at this address we have another address, and then when we visit this address, we will find the operand. Okay, so this is the indirect method. So 300 is pointing to another address, and that address is where the operand is stored. The effective address in this case is going to be 1350, because 1350 is the address at which the operand is stored. Hence, as we can see, the effective address is the address at which the operand will be found. Again, once we find the operand, we will be performing addition, and it will be stored in the accumulator register. Thank you, and see you in the next part.